this is part B of 3.3. So we started here. That was part A, and then we're here. So we're going to talk about multiplicities of zeros. All right, so here's an example of a factored polynomial. So A and B are zeros of the polynomial. So n would be the multiplicity of A, and m is the multiplicity of B. All right, so just looking at some examples here. We have a 0, so the zeros are going to be, the opposite of these numbers. So we have a 0 at -1 with a multiplicity of 2. Then we have a 0 at +1 with a multiplicity of 3. Okay, and then for that one, we would have to do, okay, there's a 1 here, so it's going to be a multiplicity of 1, but we need to do x squared plus 10 equals to 0, and we need to solve that. So subtract 10 from both sides, so x squared equals -10, and then I would take the square root of both sides. So that would be x is equal to plus or minus, and then since we're taking the square root of a negative, that's going to be I square root of 10. So that's going to be I square root of 10 and also negative I square root of 10, and those are both going to have a multiplicity of 1. So those are obviously imaginary, but they're still zeros of the function. You wouldn't be able to graph them on the graph because the real zeros are the x-intercepts. Okay, number 8, we have a 0 at +5 with a multiplicity of 1. Then we have a 0 at -3 with a multiplicity of 1. Then we have a multiplicity of 1 with a 0 of 1 with a multiplicity of 4. All right, and then we have, let's see, number 9, okay. Oh, this is kind of a funky one. All right, so let's set that equal to 0. 7x minus 2 equals 0. Let's solve it for x, so add 2 to both sides. 7x equals 2. Divide both sides by 7. So x is equal to 2/7. So that's the 0. We have a 0 of 2/7 with a multiplicity of 3. All right. Okay, then this one, x squared plus 9 equals 0. So let's solve that for x. Subtract 9 from both sides. X squared equals -9. Take the square root of both sides. So that's x equals plus or minus 3i. Okay, so 3i and -3i with multiplicity. Those each have a multiplicity of 2. All right, and then we will learn in the next section why multiplicities are important. So this is all leading up to graphing these polynomials, all right? And so this all has to do with graphing them. All right. Number 10, find a polynomial of degree 3 with real coefficients and zeros of -3, -1, and 4 for which f of -2 is equal to 30. Okie doke. So, all right, so it's going to be f of x equals, so we don't know what the leading coefficient is yet. So I'm going to put a for the leading coefficient. And we've got these 3 zeros. So that's going to be x plus 3, x plus 1, and x minus 4. All right, and then it's telling me that f of negative 2 is equal to 30. So we're going to use that information to solve for a. All right, so let's see. All right, so f of negative 2 all right, so we're going to replace all the x's with negative 2. And then it tells me that that's supposed to be equal to 30. All right, so negative 2 plus 3 is 1. Negative 2 plus 1 is negative 1. And negative 2 minus 4 is negative 6. So that's going to 1 times negative 1 times 6 is going to equal positive 6. So it's going to be 6a is equal to 30. And then we're going to divide both sides by 6. Alrighty. Okay, so that's going to be a equals 5. Okay, so f of x equals 5 times x plus 3 times x plus 1 times x minus 4. And hopefully they don't make you multiply that all out. I wouldn't, but I mean, if they do, it's just a matter of foiling and distributing and stuff. Okay, number 11 we're actually not gonna do. This is no longer in the homework because it takes a ridiculous amount of work to do it. Let's see. What we do need, though, let me replace that with something that will be helpful. I shouldn't have crossed out the instructions because we are going to use those instructions, but I'm just going to change up this part. Okay, so let's say that the zeros are 2, negative 3, and 4i, okay? All right, so in this case, what we need to know is that if you've got a 0 that is imaginary, like 4i, then you're also going to have the opposite of that as well. That way you can, because it says it has to have real coefficients, okay? So that's how you're going to basically get rid of the I. All right, so it's going to be kind of similar to the last problem. So f of x equals, so we're going to do x minus 2, x plus 3, then we're going to have x minus 4i, and x plus 4i, okay? All right, so let's see. Now it doesn't give me a thing like the last one did where it said, you know, f of something is something. So we don't even have to worry about that. It just says find a polynomial. So we can just assume the leading coefficient is 1 and that's fine. All right. All right, so let's go ahead and FOIL this part. So that would be x squared plus 3x minus 2x minus 6. So that's x squared plus x minus 6. And then let's go ahead and FOIL this part. So that'll be x squared plus 4ix minus 4ix minus 16i squared. So see there, we've canceled this out now. And we know that I squared is equal to -1. So negative 16 times -1 will equal positive 16. Okay. And so, yeah, I think we should probably go ahead and, they might let you leave it like this, but they might not. I'll go ahead and multiply it out. All right, so let's see. Let's do. So that'll be x to the 4th plus x cubed minus 6x squared. And then let's do everything with 16. So that would be plus 16x squared plus 16x minus 16 times 6. That's 96. All right, combine the like terms. So bring down x to the, most of these don't even have like terms. There's actually just those two in the middle. So x to the 4th plus x to the 3rd, and we're going to combine those in the middle. That's going to be plus 10x squared plus 16x minus 96. And there we have it. Yeah, I think you might see this type of question in like a multiple choice format, and they will be multiplied out. So yeah, so you'll have to know how to do that. Okay, last page. Descartes' rule of signs. Okay, so this is just like a little trick to help you figure out how many positive and negative real zeros that you might have. So what you're going to do is you're going to look at your polynomial and you're going to count the sign changes. So what that means is, okay, positive, 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 positive. So there are 0 sign changes in that polynomial. So that means that there will be 0 real zeros in that polynomial. So next what we're going to do is we're going to evaluate f of negative x. So we're going to plug negative x in for each of the x's. And then we're going to simplify that. So if you have a negative and you raise it to an even exponent, that negative will go away. So that'll just be x to the 4th. But if you raise it to an odd exponent, it's going to the whole term's going to become negative. All right, now let's count the sign changes from there. So it goes from positive to negative, so that's 1 sign change. Then it goes from negative to positive, that's 2 sign changes. And then it's positive, so that's not a sign change. So there are 2 sign changes right here. So what that means is that there might be 2 negative real zeros, or there might be 0 negative real zeros. Okay, so whatever number you come up with, you just count backwards by 2 until you can't, you're not going to have a negative amount of zeros, so don't go negative, but just count backwards by 2 till you get to like 1 or 0. Okay, so for example, if there were 4 sign changes, you would say 4 or 2 or 0. If there were 5 sign changes, you would say 5 or 3 or 1, okay? All right, so on number 13, let's count the sign changes. So it goes from positive to negative, so that's 1, then negative to positive, that's 2, then positive to negative, that's 3. So it has 3 sign changes. So that means there might be 3 positive real zeros, or counting backwards by 2, there might be 1 positive real zero. So there's either going to be 3 or 1 positive real zeros. And then let's evaluate f of negative x. 2 times negative x to the 5th minus 3 times negative x to the 4th plus negative x squared minus 3. So the odd exponent, so that term becomes negative, so negative 2x to the 5th. That negative right there will cancel out, so that term will stay negative. So minus 3x to the 4th. That negative will cancel out, so that term will stay positive, and that stays the same. So then count the sign changes again. So that's the same. There's a change right there, and there's a change there. So that's 2 sign changes. So there might be 2 negative real zeros, or there might be 0 negative real zeros, okay? So, I mean, the way this could be helpful, I guess it'll make more sense when we do the next section, how this might be helpful whenever we're looking to figure out what the zeros actually are. Okay, so that is the end of 3.3, and we are almost to the point where this will all come together in 3.4. It's all going to come together. All right.